Hello, we're going to make some quiz corrections right now. So you want to have your Catapult quiz open to the lab format section. You might even want a spare sheet of paper that you can write down any corrections, especially if you need to fix your trend statement or your limitations or do any writing. You might want a spare sheet of paper that you can then staple to your quiz. If you don't have any corrections for this section, then don't worry about writing anything down, but use this as kind of a quick review for you on lab format. Alright, so in the scenario you were given, two students were investigating how the distance from the fulcrum, how the counterweight's distance from the fulcrum affected the distance of the projectile. Right, so they started with the counterweight closer to the fulcrum, and then they started moving it further and further away, and they wanted to see how that affected how far the projectile would go. So it's a good idea to make sure you understand what is actually being investigated before you even answer any questions. Your table should have looked something like this. You wanted to have dV versus IV for your title. You wanted the dV here, the IV here. The averages were already calculated for you, and then the percent change should have looked like this. So at this point, if you got percent change incorrect on any of them, I want you to practice a little bit entering in the formulas for percent change and just see if you can get the right answer practicing it. So remember, we're always using the same formula. The only thing that changes is which number you put in first, right? And you probably want to label your averages A, B, C, D. Sometimes there might even be an E and an F, but label them so that it's easier to kind of create these formulas. Right? So the first one should have been 2.13 minus 1.33 equals, if you're using a calculator, then divided by 1.33, and then multiplied by 100. And you should have gotten a number like this, which you would then round to the nearest hundredth, so that it would look something like this. Right? Same thing here, except you're substituting in B for C for the first number. Everything else stays the same. You should have ended up with this number, which then gets rounded up because 0.248, 8 is higher than 5, 4 gets rounded up to 5. So just, if you got these wrong, go ahead and practice plugging it into the calculator, see if you can get the right answer this time. These are really all about repetition and practice. Your graph should have looked something like this. You should have had dV versus IV for your title, labels. Also check that you have a number line down here. I'm still seeing some people forget to put a number line for especially their x-axis. So if you just put 2.5, 4, 5.75, and 6.5 on here, you didn't do it correctly. You should have a number line. It should be going up by the same number the entire way. Right? And you should also have your grand mean plotted. It should be somewhere in the middle right here. The grand mean should have come out when you rounded to 4.56 and 2.39. And your points should have looked fairly close to the line. They were fairly close together. They weren't all spread out. And your line should be going up as you go to the right. Alright, so check your graph, just make sure you have all of that. If you need to make any changes and you want to pause the video, go ahead and do that now. So writing your trend statement, a lot of you are getting much better at this, but there are 3 things you have to remember. You have to state whether this was a linear or nonlinear relationship. If we look back at our graph, it's very easy to tell. This is a line. I would call this a linear relationship. Your trend statement should include your ranges, right? So as the distance from the fulcrum increases from 2.5 to 6.5, the average distance traveled by the projectile increases from 1.33 to 3.45 meters. I included my ranges, and if you forgot to add your ranges, which some of you did, make sure you fix that now. And then, as we just said, this was a high positive correlation. I know that because when I look at my line, my points aren't all spread out. They're pretty close to the line, so I'd call that high. And it's going up as I move to the right, which is a positive relationship. If it were going down, that would be negative, but it is not. All right, so that's our trend statement. If you need to pause to make any changes, do so now. And our next step is support with data. 3 things you need here, and there were some people that struggled with this, so this especially you want to make sure you're writing down. The first thing you want to do is talk about the percent change. Now when I say talk about the percent change, I'm talking really about the last percent change, because I want to know what the difference between the first IV and the last IV was, and what the overall percent change was between them. Right, so from 2.5 to 6.5 centimeters, that's a 4 centimeter difference. So I increased, over the course of the whole experiment, I increased my IV by 4 centimeters total. So I would say when the distance from the fulcrum increased by 4 centimeters, there was 159.4% change in the distance traveled by the projectile. Right, that's my last percent change. And that tells me overall throughout the whole experiment what was the last change. The next thing you want to do is just say whether that's significant. 159.4% I would say is very significant. If it were maybe 0.001%, I would say maybe that's not very significant. But this clearly is a significant change, and it's a positive change. This isn't a negative number, so it's positive. Significant positive change. The last thing I want to do is talk about a pattern, and this can be tricky. There's 2 ways you can do it. You can go back to your table, and you can figure out, well, every time the IV increased by this number, the average DV seemed to increase by about this number. The other way you can do this, and this is a trick I want you to try, is just look at the slope of your line. Right? So go back to your graph. Go back for a second. Go back to your graph and take a look. If I increase my IV by 1, what is my DV? It looks like it's about 0.5. So when I'm making my pattern, I can say, well, every time I increased my IV by 1, it looks like the DV increased by 0.5. I increase it again by 1, it again increases by 0.5. So there's a pattern here. Every time the IV goes up by 1, the DV seems to go up by 0.5. That's really the slope of my line that I'm talking about here. So I can use my slope to help me with my pattern statement. All right, so let's go back to the supporting data. All right, percent change, significance, and my pattern should be, on average, every time the distance of the counterweight from the fulcrum increases by 1, the distance traveled by the projectile increased by about 0.5. Right? Simple, just pattern of what's happening. Right? You also had to make an interpolation and an extrapolation here, and this is actually where some people went wrong. So the first question asked, at 5.75 centimeters, what would be the distance the projectile would travel? Right? To make my interpolation, I'd go to 5.75, I'd follow that up, and I'd see that it looks like it's right around 3. So if you were close to that number, I accepted that. Everyone's trend line might have been a little bit different. Your number might have been slightly different. But if you were close, I accepted that. And that's an interpolation because look at my data points. From here to here, anything in between would be an interpolation. Now the next one, at 1 centimeter, the distance is 0.5. Right? If I go to 1, go up to 0.5, that's the distance. A lot of you put that this was an interpolation. I think because you already had it on your graph and your trend line extended that far. But it's not an interpolation unless it's within the points that you've actually taken. So from here to here would be an interpolation. Anything outside of those points of data that's been taken would be an extrapolation. Even if it's still on your graph and on your trend line, it's outside of the points that were actually measured. Right? So only between here would be interpolation. Anything outside would be extrapolation. All right, the final thing, and this is something that some of you are getting better at. Some people are still naming sources of error and constants instead of limitations. So I just really quickly wanted to go over what the difference is. Limitations. An example would be an environmental limitation, being inside a classroom with limited space versus, let's say you were outside where there's wind and weather that could be a factor. These are limitations. These are not things that necessarily are sources of error, right? They just kind of limit your data. You can only do so much if you're in an enclosed space. Doesn't mean you're going to get inaccurate data because you didn't make an error. It just means that if you want to test something that's a much larger distance, you can't really. So it's a limit. Right? Same here with equipment. The equipment could only hold so much weight. You can only test so many IV variations. Doesn't make it inaccurate. Doesn't mean it was an error. It just means there's only so much that you can test. Same with measurement. Sometimes the tools you have to measure only allow you to measure so much. Right? Doesn't make the data inaccurate. Isn't a source of error. Just that you can only measure so far unless you find other tools. A source of error, on the other hand, or a constant, those are things that people actually did wrong, and they can actually lead to inaccurate results. So a constant that you want to consider, which a lot of you put for your limitation, would be having the same person launch the catapult each time. That's not a limitation. That's something you want to keep constant in your experiment. Measuring incorrectly, that would be a source of error. That's human error, and that means that you probably will get the wrong results. Not a limitation. Changing one variable at a time, again, that's something that you'd think of as a constant or a source of error. It's not something that is a limitation to your experiment. All right, so if you got any of that wrong, I want you to rewrite it. Try to use one of these examples, one or two of these examples, and just compare. See how they're a little bit different. And also make sure that you included the type of limitation, because I did give you a list of types, so make sure that you understand the difference between those types. Alright, so that's about it. If you have any further questions, come and let me know. Don't forget to get your quiz correction signed and brought in tomorrow. Have a great night.